Okay, here's our very first lesson of this unit, and this unit is called linear relations. So it's going to build on relations and functions, but we're specifically going to focus on linear relations. So what makes a relation linear? How do we make the equation of a linear relation? There's a lot of ties to the grade 9 math curriculum here. And we're going to introduce some new ways of looking at it, or new formulas at looking at it. And so today we're looking at slope, and you've seen slope a few times before. So this should be review. That slope is rise over run. Okay, so slope is rise over run, and rise would be your vertical change. Let's use a pen, 1 second. So rise is going to be your vertical change, right? Your vertical height, and then your run is your horizontal change. So you always have to rise before you run. Get up in the morning before you can start running. So rise over run. A rise is positive if we're moving up, and it's negative if we're going down. So positive, right? That just like makes sense, like the y-axis, and down is negative. Right is positive for our run, and left would be negative. So if we look at these, I always like to say when we read a graph, you read it like a book. We go left to right. So if we're looking at like endpoints A, B, we're going to go from A to B, from left to right. And we should go rise. We want rise over run. So we're going to make a triangle, right? We go our rise first. So we're going up 2. So that's a positive 2 because we're going up. And our run, we count the boxes. 1, 2, 3, 4, 5, 6, 7. 7 to the right is a plus 7. And so our slope is 2 over 7. Positive 2 divided by positive 7. So if I'm looking at CD, I'm going to go from D to C. Because CD and DC are the same line. Doesn't matter the order. So we want to go up. So we're going to make this triangle. How many did we go up? 1, 2, 3, 4, 5. So plus 5. And 1, so plus 5 is my rise. 1, 2, 3, 4. Plus 4 is my run. And so that'd be 5 over 4. And then EF. So again, if we look at this EF, E is on the right. So let's do our rise first. I'm just going to erase the other guys for now so it's not in the way. And okay, so rise is actually we have to go down, right? So we're up or down direction first. 1, 2, 3, 4, 5. So we're going down 5, so negative 5, and right 3. So down 5, right 3. Right is positive. So our slope would be negative 5/3. Okay? All right. So we want to always move from left to right, just like we read a book. And we do our rise first, then our run. I got to rise before we run. Okay, so we're going to... Basically, this investigation 1 is showing how if we have points that are on the same line, and those points are called collinear. Collinear points are on the same line. So collinear, they're all going to have points. So they're on the same line, have the same slope. So if the slope from A to B, I like to do rise and run. So 2 and 1, 2, 3 is 2/3. Okay, the slope's 2/3. So AC, although those are different numbers, when we simplify this, okay, so we count 1, 2, 3, 4, 5, 6, 7, 8, and we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 8 over 12, that still reduces to 2/3 as our slope. And so the slope of AD will also reduce to 2/3 because they're on the same line, so the rate of change will be the same. The slope is the same. BC will also have, once it's reduced, the same slope of 2/3. Okay? So let's talk about horizontal lines. What is the slope? Well, let's think about rise over run. If we look at A, B, I want the slope, and the symbol for slope is M. Okay, So if I want the slope of AB, well, let's think about our rise. How much did we rise? 0 over 1, 2, 3, 4, 5, 6, 7, 8. 8, 1 is 8. 0 divided by 8 is 0. So whenever you have a horizontal line, all of these in grid 1 are all horizontal. A, B, C, D, E, F. The slope is 0. Okay, because whenever it's horizontal, it's 0. When you have a vertical, let's look at, for example, let's go GH. Okay, so slope, or M, is equal to rise over run. How much did we rise? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divided by our run. Well, how much did we move left or right? Well, we didn't. We stayed in the same position. So 10 divided by 0. Can you divide by 0? No. So that's undefined. So when you have a vertical line, the slope is undefined if it's vertical. Okay, so horizontal line segments have a slope of 0. Vertical line segments have a slope of undefined, an undefined slope. Okay, and that's really, you have to remember that. You could use rise over run to help figure that out too, right? On the next page, we're just briefly looking at positive and negative slopes. So everything in grid 1 is a positive slope because it's rising to the right. It's rising to the right. And this is, all of these here are negative slopes because they are falling to the right. As we read the graph left to right, it's falling to the right. Okay, so negative slope versus positive slope. We're not going to fill in this grid. Basically, a line which rises from left to right is positive, and a line which falls from left to right is negative. So you can also use slope man to help you figure that out. And slope man looks like this. So that would be rising to the right, positive. Falling to the right is negative. A vertical line is undefined slope, and a horizontal line has a 0 slope. And that, my friends, is slope man. He's sad or something, but cute. Okay, so we're going to turn now. Let's look to the next page. I am going to skip example 2. We're going to go into example 3. So draw a line segment on the grid which passes through the point -4 and 2 and has a slope of -2/3. So -4, 2. Let's plot that point first. 1, 2, 3, 4 to the left and up 2. So there's my point of -4, 2. Now, when you see a slope that says -2/3, the question is, where do we apply the negative? And I always apply it to the numerator. This way we're always moving right. So that means my rise is -2. So if this is rise and my rise is -2, what direction are we going? That would be down 2. And because this is a +3, we're going to go right 3. So this way we're always moving to the right, because if there is a negative, we'll apply it to the numerator. And so that will just determine if we're going to go up or down. So down 2, right 3. Down 2, right 3. And we can follow that pattern of down 2, right 3, down 2, right 3, down 2, right 3, and so forth. It says write the coordinates of 3 other points. Well, there's 3 other ones. So there's one at -1 and 0. Right? There's one at positive, x is +2, and y is -2. And another one at x is +5, y is -4. Okay, and so we want to connect that line. So if you have a ruler, that's great. If not, you can use your calculator lid, I always say. Works fine. I just need to fix that. Let's try to fix this slide a little bit. All right. Now you could have applied the negative to the denominator, and you would have got the same line, because then if you apply the negative to the denominator, I'll just show you, instead of 2 and -3, then a +2 over -3 is the same thing as -2 over +3, right? And so this would be up 2 and left 3. Left 3. So if you could see, if I went up 2, left 3, I still would land on that same line. I like to always move towards the right, and so I like always applying it to the numerator. It's also in math we don't like negatives on denominators. It's not proper, so that's another reason why. Okay, let's look at the last one here. It says a line segment has a slope of -5/7 and a rise of 12. Calculate the run. So they tell us that our slope is -5/7. And notice how I apply it to the numerator again. Just habit, doesn't matter. It has to apply to one of them. And we know our rise is 12, and they want us to find our run. You can call that x if you want. So we know slope is the same thing as rise over run. And what is our slope? Well, our slope is -5/7. So -5/7 equals the rise of 12 over the run of x. Okay, so from there we want to solve for x. It's on the denominator. So you can either cross multiply. So if you cross multiply here, you get -5x equals 7 times 12, 14, carry the 1, 84. And then last divide by -5. Okay, so x would equal to -84/5. I'll just put that negative out front. And so that's what your run would be. And if you want, you can figure that out as a decimal. The other way you could have solved this without cross multiplying is you need x off the denominator. So I would have multiplied both sides by x. It's essentially the same thing as cross multiplying, and then, so I would have had -5/7, x equals 12. And then you could just divide both sides by -5/7, or if you want to just first take care of the 7, multiply both sides by 7, the 7's cancel, and you get 84 again, then divide by -5. Okay, so that's the other method without cross multiplying. It essentially is the same thing. It's a little bit more proper because there are cases in math that you'll see, especially in Math 20, where you can't cross multiply. All right, we're going to quickly turn over to lesson 5 now. And so this was a review of rise over run. Some new stuff, but mostly review. And so let's go through this first one here, this first review. Slope is the measure of the steepness of a line. Okay. So if you want to try these, you can pause the video here, fill them in, and then see if you're correct. Slope is the ratio of the vertical change called the rise over the horizontal change called the run. A line segment which rises from left to right would be a positive slope. If it falls from left to right, it's a negative slope. A horizontal line segment has a slope of 0, and a vertical line segment has an undefined slope. The slopes of all line segments on a line are slopes of all line segments on a line. So what they're saying is all line segments, AB, BC, AD, they're all going to have equal slopes if they're on the same line. They're called collinear. Okay. All right. So we're just going to look at part of this example. So let's just look at AB and ignore CD and EF for now. So we know that it's rise over run, right? And we know that this here, let's look at the coordinates of A. A is the coordinate of 1 and 8. Okay? And B is the coordinate of 6 and 11. Okay? So notice, what do you notice? We know the rise. What is the rise of AB? So the rise we know is actually 3, right? We can count that, 3. So looking at the coordinates, if we're talking about rise, are we talking about the x variable or the y variable? We're talking about the y variable, right? So what's the relationship between this rise of 3 and the numbers 11 and 8? Do you notice that the difference between them, 11 minus 8, also gives you that rise of 3? So if you subtract their y values, yb minus ya, the y value on b and the y value of a, we get 11 minus 8, which is 3, our rise. Okay, now our run, notice our run is, if we count this, 1, 2, 3, 4, 5, 6, and we look at the x coordinates, because run is x, right? And we're going from 1, did I count this right? Oh, my coordinates should be 7. You probably already noticed that. Sorry. 7, 11. Don't run out and get a Slurpee on me. Okay, so if we look at 7, 11, we go from 1 to 7. The difference between the x value, because we're talking about a run, and run is horizontal. So xb minus x of a would be 7 minus 1, which gives you that run of 6. And so we can use that to actually make our formula for slope. Because slope then would be y, the rise, which is the difference of the y coordinates, over the run, which is the difference of the x coordinates. YB. There you go. So which gave us, in this case, 3 over 6, or that was a slope of 1/2. So that was using the formula. So this is basically the formula that's on your formula sheet. Instead of B and A, I believe your formula sheet's 1 and 2. So 0.1 and 0.2. Oh, where'd this go? Uh-oh. Let's try this again. Lesson 5. Unless I actually just added a page. Nope. It's missing. Give me one moment. Okay, so here it is. This is the formula on your formula sheet for slope. If you're given 2 points, and you're not given a graph, if we could take to get the rise, we want the difference of the y values. To get the run, we want the difference of the x values. And so we want to do, if you have 0.1, which 0.1, let's say, is, you'll call it x1, y1, and 0.2 would be x2, y2. So it's important the order which you subtract. So it'd be 2 minus 1, right? y2 minus y1. So y2 minus y1 would give you that rise difference, divided by x2 minus x1 will give you that run difference. And there's our slope. So for example, if we have this point here, I like to label my points right away. x1, y1, and x2, y2. I see in the example they use 8, like they label them h and g. That you can do that as well if you prefer. I like to just go x1, y1, x2, y2, so 0.1, 0.2, because that matches your formula sheet. And so when we want the rise, we want the difference of the y values. So I want y2 minus y1, negative 2 minus 8, divided by, and now we want the run, which is y2 minus y1 was the rise. Now x2 minus x1. Now you have to be careful here when you're subtracting, because if I'm subtracting a negative 3, what happens? If I go 7 minus negative 3. Well, 7 minus negative 3, if you subtract a negative, it's the same thing as adding a positive. So that becomes a 10. Negative 2 minus 8 is negative 10, so that simplifies to a slope of negative 1. Okay? All right. So, okay, let's see there. Eleanor, Bonnie, and Carl are calculating the slope of a line segment with endpoints 15, 8, and negative 10, 6. Their work is shown below. Since their answers are all different, at least 2 of the students have made errors in their slope calculations. Determine all the errors which have been made and determine the correct slope. So, Eleanor, so slope of EF. Okay, so she made, you can see this is, the formula for slope is x1 minus, rise y2 minus y1 over x2 minus x1. Okay, so if I was doing this problem, I would want to label, it doesn't matter which one's your first point. It looks like because y2, see, she put in y2 as negative 10, but that's an x value. So Eleanor's mistake here is she subtracted, she was doing the run divided by the rise, so that's not correct. Okay? Now let's look at Bonnie. So Bonnie went 6 minus 8. 6 minus 8, is that correct? So if we call this x1, y1, and this x2, y2, let's look. Y2 minus y1 would be 6 minus 8. That's good. And then we'd need to go x2 minus x1. Well, here's the problem. She went x1 minus x2. So these are mixed up. They're switched. So that's incorrect. Okay, so let's find it. I'm going to not even go through Carl's. Let's find the slope ourselves, okay? And then we'll see. It looks like Carl would be the right one because so far both of these guys are right. Now, if I have the points 15 and 8 and negative 10 and 6, my first step should be labeling my points. x1, y1, x2, y2. Now, for fun, you could actually do it the other way if you wanted to. So you could say, I'm going to make point 1, x1, y1, and this one, x2, y2. I'm going to do it both ways. It doesn't matter, but notice that if whatever your x1 is, the y1 is in the same coordinate. So if we find the slope using our slope formula, which is rise over run, or the change in x, or y over change of x, so let's use this guy first. So 6 minus 8 divided by, so we went y2 minus y1. So notice I'm going second point minus first. And then x2 minus x1. So divided by negative 10 minus 15. So 6 minus 8 gives me negative 2. Negative 10 minus 15 is negative 25. Okay, 6 minus 8, negative 10 minus a positive 15. Now, what does that equal? That equals a positive 2 over 25. So all three of these guys were incorrect. Let's just make sure I did this right. So we have the point 15, 8, negative 10, 6. So 6 minus 8 is negative 2. Negative 10 minus, negative 10 minus 15 is negative 25. And if we subtract, a negative 10 minus is, and so two negatives gives us a positive 2 over 25. Okay? So let's do it this way. What if I labeled them the other way? So I made this my first point. So again, using y2 minus y1 over x2 minus x1. So now y2 is 8 minus 6. y2 minus y1 over x2, 15 minus negative 10. So 8 minus 6 is 2. 15 minus negative 10. Well, when you subtract a negative 10, what happens? It becomes a plus 25. So notice how we get the same slope. It doesn't matter how you order the points. Okay, it doesn't matter who's the first point or who's the second. What matters is the order of subtraction. That you're always going their second point minus your first for your y's, and then second points minus your first for your x's. Okay? So here's this idea of collinear points on the next page. So points that are on the same straight line are called to be collinear, and collinear will have the same slope. Okay, the slopes are equal if they're collinear. So if I was to prove, this is our last example, if I was to prove that these points are collinear, okay, I want to do a proof. In order for them to be collinear, then we need to prove that the slope of AB is the same as the slope of BC. Because if the slope of AB is the same as the slope of BC, then they're on the same line. They're collinear. Okay? All right. So here we go. Let's start with finding the slope of AB. So AB, what are my points. A was 5 and -3. And B is 2 and 6. Okay, so I'm going to label this A is my x1, y1, and B is x2, y2. And so we're going to plug it into the formula y2 minus y1 over x2 minus x1. I'll zoom in. Okay, I'll show you how to do this all in your calculator in a second. So y2 would be 6, right? Here it is, 6 minus y1 is -3. So you want to put brackets in there. Divided by, so there's your y1. Now we want x2 minus x1. So 2 minus 5. Okay, now if I did want to plug this into my calculator, I find it safer just to like evaluate the numerator, evaluate the denominator, but you can use your calculator, okay? So if I wanted to use my calculator for this and type this all in, you would need brackets on your numerator. So bracket around your numerator, 6 minus -3, and technically I don't have to wrap the -3 in brackets when you plug it in. You just need to wrap your numerator and your denominator, 2 minus 5, okay? And so it gives me a slope of -3. If you have the alpha y equals option of numerator over denominator, in many ways that's easier, right? You're less likely to make a mistake than 2 minus 5. So you have to remember those brackets, -3. So we're expecting to get a slope of -3. All right, so let's check this. 6 minus -3 is the same thing as 6 plus 3. So that gives me a 9. Divided by 2 minus 5 is -3. And 9 divided by -3 is -3. Okay? All right, so that was finding the slope of AB. Now we need to find the slope of, just going to get my eraser or remove some stuff. Let's move this out of the way. Okay, now let's find the slope of BC. I could have also done AC. That would have worked too, slope of AC. And then that would have proved collinear if it's collinear as well. But we're going to use AB and BC. Okay, so we have point B. I'm just going to use what's up here. I'll label B as my x1, y1, and my C is x2, y2. All right, so y2, 33, minus y1, 6, divided by x2 minus x1, -7, minus 2. Okay, so again, if you want to use your calculator, you're welcome to. Close the other version, sorry. So numerator over denominator, or brackets, 33 minus 6, bracket, divided by -7 minus 2, bracket. And that gives me -3 again, yay! Or 33 minus 6 is the same thing as 27, divided by -9, which is -3. So therefore, yes, they are collinear. So since the slopes are the same, the slopes are equal, they are collinear. Okay, it's 2 L's actually. Collinear. There you go. All right. And it says find the value of y if the point -4 and y lies on the same AC. Okay, so here's the thing. We know if it's on the same line segment, then it has a slope of -3, right? And so we have the point of -4 and y. That's point D. And then we need to choose any other point on that line. So let's do AD, okay? Let's use point A. Point A is, what is that? 5 and -3, okay? And so I'm going to use the slope formula because I know my slope. I know x1, we'll call this one x1, y1, and this guy x2, y2, okay? So let's look at what we have here and plug in what we know. Here's my slope formula right here, okay? What do we know? We know our slope, right? We know the m value. The slope, if it's on the same line, the slope is -3. I'm just going to erase all this silly stuff here. distracting. There we go. Okay, so negative 3 equals y2 is negative 3 minus y1. Well, we don't know that, so we're just going to minus y. So negative 3 minus y equals, and now x2, 5 minus negative 4. So let's simplify this a little bit. Negative 3 equals negative 3 minus y divided by what? So 5 minus negative 4 is the same thing as 5 plus 4, or 9. Okay, so we want to get rid of this denominator of 9 because we want to isolate y. So before we can isolate y, we have to get rid of the 9. So because it's being divided by 9, we're going to multiply both sides by 9. And I get negative 27. So negative 27 equals negative 3 minus y. We're isolating y. So now I'm going to add 3 to both sides. And I get negative 24 equals a negative y. And so we want y, not negative y. We'll divide by negative 1. And y must have been 24. And so point D would have been negative 4, 24. Okay? And that's just subbing it into our slope formula. All right, that is it for today. The assignment is from lesson 4 and 5. So from lesson 4, sorry, I have it right here. It is page 523. You can, numbers 1, choose any two. So I'll open it up here. So here, choose 2 of these. Choose 2. Number 2, choose 2 lines to find the slope of. Any 2. So number 3, if you turn the page, 4, A, C, E, and F. Number 5, A, C, D, and F. Number 7. Okay. Number 8 is an AP question, so it's optional for those who are not AP. And then 9 to 11, so 9, 10, and 11. And then on lesson 5, the assignment would be number 1. Number 2 is A, B, and C. A, B, and C. 3, B, and D. 3 is B and D. Okay. Turning over, 5, A and B. 7, so not 6. Just go to 7. Numbers A, B. Oh, where did I go? Sorry. 7, A, and B. C is optional. It's an or AP question, so AP students, you must do it. Everyone else, it's optional. And it's a good question, so if you have time, I'd say do it either way. 10 and 11, or 9 and 10, the last one. 9 and 10. Okay, so that's your assignment for this lesson. And yeah.